Hi, folks. Joseph Kursky here with you to talk about week 8 of our course. We will dig into physical regions. There's so much to explore with physical regions that we are committing 2 weeks to physical regions. This week is part 2 of physical regions. As usual, here is a checklist to keep you on track for week 8. Watch this video. Read the weekly readings, respond to the weekly readings in the discussion. I'm loving the discussions. I'm hoping that you'll have time to go back to the discussions and look at what I and others have commented, perhaps on your own posts. But the weekly readings and the discussions, also read the weekly place, thought leader, tool, event, and geographic oddity. Complete the activity using some fascinating geographic tools and data, and then complete the response to the activity and the weekly quiz. Now, the readings for this week are about physical regions. We haven't talked about rivers a whole lot yet, so I thought it was important to spend some time on rivers. They're usually hugely important to the world. Their erosional capabilities form many of the world's narrow and wide valleys, as well as floodplains, deltas, and many other landforms. They carry sediment and chemicals from the land to the oceans. They're important to cultural geography as well because their water source and their ability to transport items via boats and ships became the reason why many towns were formed on those lakes and rivers. For example, Vienna on the Danube, London on the Thames, Cairo on the Nile, Baghdad on the Tigris, and so many more. Now, even today, rivers are major routes for the transportation of the world's raw materials and finished products. Chances are the phone that you're using or the computer that you're using right now were transport at least some of the components via rivers. And their deposition and meandering action created some of the most fertile areas on the world surface, which gave rise to major agricultural zones and then the flourishing of human population. So chances are the food that you ate yesterday was grown in a river valley. Investigating the ocean floor is something else that's going to be key to this particular week. Hills, canyons, plains, and other landforms do not end at the edge of the land, right? But oceans and even larger lakes of planet Earth can be better understood by examining their underwater forms, their bottoms, their floors, okay? So we're going to explore a set of ocean floor areas in a 3D scene, which I hope you'll find interesting. We're also going to talk about volcanism and earthquakes and volcanoes here. This is natural regions. One of the most dramatic changes in recent history and a powerful reminder of our dynamic Earth was the explosion at the Hunga Tonga Ha'apai Islands in the South Pacific Ocean. We're going to look at some satellite imagery and some maps to look at what happened there not that many years ago, and we're going to compare the eruption that happened there and the island building and then the consequent blowing up of the whole thing a couple years after that. So we're going to examine that. This week in our Place, Thought Leader, Tool, Event, and Geographic Oddity section, I hope you'll enjoy that because the place is the lowest points on land and sea. The thought leader is going to be Dr. Deep Sea Dawn Wright. Deep sea is her motto for herself because she descends into many, many deep trenches in the ocean, among many other things that she does. But Dr. Dawn Wright, Chief Scientist at ESRI, is going to be our thought leader this week. The tool is going to be the Ocean Ecological Marine Units web mapping application. We'll be able to look at dissolved oxygen, salinity, and other variables across the world's ocean. The world's oceans are not just a single blue-green mass. There's a lot of variability in the world's oceans that affect life on land, including our own. The event, we're going to talk about the vindication of Alfred Wegener from the continental drift plate tectonics side of geography. And the geographic oddity, we're going to be talking about Tristan da Cunha. The Tristan da Cunha is a remote group of volcanic islands in the South Atlantic Ocean, and we are talking very remote here. First, it's political geography, but also it is the most remote inhabited island in the world. So I hope that's interesting for you. The activities this week, we're going to examine landforms in 3D. And one of the questions in there is how much would a certain mountain weigh? So you're going to do a little bit of calculation there. It's going to be quite strikingly heavy, how much a certain mountain weighs. And that's just one mountain. So we're going to look at landforms in 3D. We're going to look at landforms via elevation profiles. These are 2D representations of, hey, if you're biking or walking across that surface, is how hilly is it going to be? So we're going to make some landform profiles. You're going to make some landform profiles in this week's activity. And you're going to reflect on what you learned there via the discussion and also via the quiz after that. You didn't think I'd forget my geographic geo song for you all this week, right? No, here it is. They asked me if I knew if my map was true. Oh, I of course replied, this I do confide. All maps tell some lies. Now, why do I say all maps tell some lies? Because maps are a representation of our complex Earth. They all have issues with their accuracy and the representation, the map projection, the data that they have, the data they exclude. So all maps unintentionally tell some lies. So you need to be critical of all maps. They're very useful, but they all lie to some extent. And we'll talk more about that in the course. So that's why I chose the Geo Song for this week, to get you thinking critically about maps and geographic data. Okay, we will see you in week 8, part 2 of physical regions. Thanks for being with me.